Welcome to this tutorial for blinded sample size re-estimation in nQuery. In this tutorial, we will take a standard 2-sample t-test sample size calculation and show how it can be extended using the blinded internal pilot approach to increase the sample size if our original estimate of the standard deviation had been too small. Blinded sample size re-estimation is a widely used and widely accepted type of adaptive design where, based on blinded interim data, in other words data in which we don't know which group each subject's data is from, to get a better estimate of a nuisance parameter used in our original sample size calculation, such as the variance or the over-dispersion parameter from a count model. The internal pilot approach is one of the simplest ways to do a blinded sample size re-estimation. In the internal pilot approach, we take the first cohort of patients as an internal pilot, and using the blinded data, we re-estimate the nuisance parameter value, for example, the standard deviation. If the standard deviation estimate is higher than we expected in our original sample size calculation, we simply recalculate the sample size using the improved estimate, and once the study is over, we can analyze the data as if the internal pilot did not occur. We can do this without affecting the overall type 1 error rate if we are doing a superiority or inequality type hypothesis. In nQuery, a blinded internal pilot sample size re-estimation is done in two parts. Firstly, we need to replicate a sample size calculation. In this case, we'll replicate a New England Journal of Medicine study where they were evaluating cyclophosphamide for scleroderma disease. In their study, they assumed a 0.05 significance level at the two-sided level with a difference in means of 9 and a common standard deviation in each group of 16. Giving an effect size of around 0.563. In their study, they wanted to have 90% power, which required 136 patients in total. To extend their example to allow for a blinded internal pilot sample size re-estimation, we first need to specify how big that internal pilot would be. Common values would be 50% of the original sample size, or other interim sizes based on the external pilot literature. In this case, let's use a relatively small internal pilot of 20 subjects. We could enter the updated estimate directly into the main table, but nQuery comes with a convenient side table in which we can take some internal pilot data and then use certain rules to calculate the best estimate available for that interim updated standard deviation. This side table consists of two parts. On the left-hand side, we have the rules that we want to use to calculate the standard deviation or variance. And on the right-hand side, we have a field in which we can enter our internal pilot data, which will then calculate the best estimate based on our rule set. We have three different rules for how to calculate the variance or standard deviation. There's the one sample variance, in which we simply take the overall variance for the internal pilot as being equal to the per group standard deviations. We have the bias adjusted variance, which attempts to remove the effect of the between group difference effect. And then there's the upper confidence limit approach, which is from the external pilot data study literature, in which we take the upper confidence limit for our estimate of the variance and standard deviation based on the size of the internal pilot. In this case, let's use the one sample variance approach, as this is advocated by Kaiser and Frieda in one of their review papers as being a good estimate in general. Once we selected this rule, we simply need to enter our internal pilot approach in this field on the right-hand side. In this case, we've simulated some data assuming that the standard deviation in each group was equal to 20. And this simulation gave an overall variance of around 19.89. We will simply copy and paste this hypothetical internal pilot data into the data field of the side table. And then you can see that the internal pilot standard deviation estimate is equal to 19.896 using this rule set. You can also see what the standard deviation would have been under the bias adjusted and upper confidence limit approach in these rows below that. Once we have filled in this side table appropriately, the standard deviation has been transferred automatically into the relevant row of the main table. And you can see that the sample size requirement has increased from 136 in total to 208 in total, and that we need 188 additional subjects after the original 20 in the internal pilot to get sufficient power, assuming that the variance or standard deviation is exactly equal to this value. The restricted and unrestricted sample size will be the same if our updated estimate is greater than the original standard deviation. However, if it is less, in that case we have an option of whether we would want to decrease the sample size from the original planned sample size, or whether we want to ensure that we have at least the original sample size planned occur in our study. The restricted sample size is that in which sample size increases are not allowed, and in this case we would still have to continue for 116 subjects after the original internal pilot. However, if we allow sample size decreases versus the original study sample size calculation, we would only need 34 additional subjects based on their standard deviation being exactly equal to 10. However, in a blinded sample size re-estimation, we are usually only interested in sample size increases, and thus either of these will be usable in that case. To learn more, visit statsolves.com. Thank you for watching.